Carolyn, that's a look of, so a question you want to ask.
I don't know what question I wanna ask, I'm just confused.
You want to just sort of stumble through it and see if we can figure it out?
You just said something about there being perpendicular, but those are parallel.
That is perpendicular to the surface. That's what I'm talking about. The normal force is perpendicular to the surfaces of contact, so since
Okay.
this is at that angle right there, perpendicular would be in that direction. And then that one is opposite that.
Yeah, I wish I used a whole sheet for this one.
It's still unsettling for you, I gather.
Hold on. If the normal force is the thing keeping them from going through each other, why are they pointing towards each other?
This is the force on the rod, trying to keep the rod from going through the hand. That's the force on the hand from the rod, trying to keep the
Oh, okay.
hand from going through the rod.
Never mind, it was just where the person was, messed me up.
Yeah, I sort of picture him there.
Never mind.
Okay. Other questions or concerns?
So when, this is like, kind of not sort of, but like, so when people say like, if atoms don't touch, how can, like, why can't I just go through this table? That's normal force?
Yeah.
That's what prevents that from happening?
Yeah, that, at a macroscopic level, we just call that normal force.
What else would it be called? Or is that the only name that you know?
At ultimately in quantum physics, the explanation comes down to Pauli's exclusion principle, that half-spin particles can't go through half-spin particles. The electrons are protons, neutrons are all half-spin particles, and they can't go through each other.
Wow. Okay.
In terms of the name of a force, you've got intermolecular bonding. So I got the two atoms here which have a force like that, and if something tries to go through them, unless you overcome that, what's binding them together, it's gonna bend some, and as it bends, so that force was like, let's see, is it bends, you get the force like that, which, oh, there we go, something was off there. So it starts out being pulled towards each other. As it bends, you now have an upward component for those forces, which is countering the force acting down. Cool. Is that good enough?
Yes.
All right.
Alright.
All right, friction. Not that one. Let's see. Ooh, that will show up nicely. And thicker. All right. Yes, Ibrahim.
I don't, no, correct me if I'm wrong, but I do not think that there is friction between Garog and the sled.
Why not?
Because I think that Garog is with the sled.
Except I drew them as separate objects.
So now Garog and sled have friction. Never
Well,
mind.
that depends on if Garog is moving his feet, I think, or sliding, basically.
Assume that all the objects are moving at the same acceleration.
Yeah.
But valid point. And so if the sled were frictionless on top, which way would Garog move? Garog would go to the left.
In the direction.
If it were, he's only onto the rope, looking at the forces here.
Oh, and he goes left.
If he's going left, if
He's
you
like,
market that, design it and make it and market it, you'll become wealthy almost overnight. Once you get past all those physicists that will go, that's impossible. So if he's only on, if I'm being pulled that way, and I've got and I'm standing on ice or something with a low friction, which way am I going to move which way am I gonna move?
Well,
The way,
Wherever,
Where you're being
whatever way, yeah.
Yeah, if I'm being pulled that way,
Yeah.
I'm gonna go that way. I'm gonna go in the direction I'm being pulled. Just like right here, if there's no friction, well, the only horizontal force I have is from the tension right here, and that's this way. So friction wants to oppose that, so friction would be acting this way on Gerard. And where's the other part of that pair?
the sled,
Going,
the opposite direction.
a bit too thick for the subscript there, but let's see. Sure, good enough. Now, if you get on a test and you want to use colored pencils, not, most people don't, but if you want to, we've got some down in the other room, I can just go grab some and bring them in if you want to use colored pencils for it.
Then you have friction on the bottom of the sled and then the ground.
All right, which,
The sled's friction is going to the right and the ground's friction is going to the left.
so road friction is so it's going like that?
Yeah, if your bottom hand is going this way. It's
I-
like, this is the sled and this is the ground.
All right, so the road is using friction to push the sled that way.
No, it's the opposite direction.
The road is trying to stop the sled from going that way,
I would imagine so if it's just being pulled along.
therefore the friction's acting this way on the sled.
Oh, okay. And then it's,
Again, David Blaine, you're down here, David Blaine, you're looking at it, the sled's going that way,
yeah,
and Blaine goes, no.
yeah, it's going this way.
Now, hypothetically,
Uh-huh.
can, like, do you see how they've drawn it like a good distance from the actual thing? Does that work?
Yeah, because there's a difference drawing it here and drawing it here. If you draw it here, if you draw it here, that could be, which object is the person talking about? But down here, there's nothing, it's the bottom thing, so I'm assuming it goes with it.
Right.
That pair is supposed to be connected there.
I have a question. So
Yes.
for the box on top of the car,
Right?
does it just slide off or is it like tipping over?
The box on top is going with the vehicle. It's also accelerating that way.
Okay.
If it were sliding off, generally on a test, I give a paragraph describing this kind of detail. And if I left something off, one or two things happens. Someone mentions it early enough and asks, and I put a correction on the board. Or two, I have to accept multiple answers, which I don't enjoy doing, but it has happened. So if the box is not sliding off, which way is the friction acting on the box?
Against the, desired motion.
So what's the desired, so the friction's acting that way on the box?
Yes, sir.
What's the desired motion?
That one.
Relative to what it's touching.
Hmm.
If this were frictionless, what would the box do?
Slide off to the left.
Yeah. From the car's point of view, or the truck's point of view, the box wants to go that way.
Right.
It's not relative. Therefore,
That way.
oh, yes, I'm sorry, I was confused earlier when we pointed the other direction.
No, yes, I was very much wrong pointing that way. Now I'm pointing this way. So now you see this has become this.
So does that mean that there would be friction between the truck and the ground?
Yes, there
And
is.
then it would be the same way as the box to the truck?
Same way as box to truck, so you're saying to the left?
Yeah, that the, like the.
Let's address that. There is friction between the wheels. If you've ever driven on ice, you know how difficult it is on a low friction surface to actually move.
But the wheels are going that way. So would you, the truck be going that way?
The truck is accelerating that way.
That's friction.
And so you're making the argument, therefore, friction on the truck is the opposite of that? Or you're saying, which way?
Okay, I'm saying that the truck's friction is that way and then the ground is this way.
Ah, okay, so the friction, but isn't the truck moving that way?
Yeah, that's what I'm confused about, like,
And that, I'm glad you're noticing that. Why are you saying that the friction's that way?
because that's the motion the wheels are going, like because the acceleration's going that way.
Okay, so there has to be something in that direction in order to accelerate it. So yes, absolutely, friction is indeed going this way, friction truck, and then friction truck. All right, let's justify it though. Well, first off, if you've ever been in mud or loose gravel and you know that if you gun it, stuff gets shot out behind, that's this right here. This is what's shooting the mud or the rocks behind the vehicle, or Garrow. Now,
Oh, poor Carol.
What?
No, but he's smiling, never mind.
good thing they're on good solid pavement. Let's think about what the friction is opposing. The friction is not opposing the truck. What is actually touching the ground? So if I want to go that way, which way will the wheel turn? So at the point of contact, which way is the wheel moving? And friction opposes that. Friction is opposing this movement down here, so therefore the friction on the tire is opposite that, in that direction.
So it's not the whole wheel, it's just whatever it's touching?
Yeah. And if you're not, we put it on this, thank you, Micah, for volunteering your lab here. As I turn the wheel, notice this is pushing the papers that way. So that's this force right here. Tristan?
When you start labeling like the friction and stuff for the car, do we just put the friction is just on the wheel then?
Wait, sorry, missed the last part?
Do we just put the friction is just on the wheel instead of the car?
Yeah, I mean, it ultimately, if you draw that FT, anywhere in here, I would accept it, but part of the engineering training that I've had, I tried to put the force where the force is being applied. So that's why I tend to draw it there, but if you drew it anywhere else, I'm good with that. As long as I can easily associate it with the truck or car, whatever it is. Evening?
What is the desired motion of the truck at this point?
Truck is moving to the right and accelerating to the right.
So then why is the friction also going right?
What other force do we have acting to the right on the truck? There has to be, pardon?
Garrog at his rope.
The rope is pulling the truck backwards. Therefore, magically, if you're pulled to the left, you move to the right. Again, wealth, almost overnight.
No. The car wants to go this way. It wants to go right.
It is going that way.
It is going right.
I don't know what the car actually wants, but that's what's happening to it.
Friction is the opposite to desired motion.
Desired relative motion.
Desired relative
That is
motion.
absolutely true.
So if the desired relative motion is right, then why is the friction not left?
What is actually causing the friction? What part of the vehicle is causing the friction?
Wheels and ground.
Yes, it's the wheels. Pull out the wheel again. If I want to go that way, the wheel is going to be turning like this.
Right.
Look at the bottom. Which way is the bottom of the wheel moving?
That
Yes, that's what the friction is opposing. The desired motion of the point of contact is that way, and so therefore friction is acting that way on the wheel.
oh.
The wheel's rotating like this.
So the part of the wheel that's contacting the ground is going this way So that's what it opposes.
Yes.
That way.
Yes.
Oh. I said so soon. Anyway. I got it.
Sorry for not talking about that soon. I just assumed everybody did. All right, we've got, 1, 2, 3 more pairs.
Does, the chair move at all, or is it like bolted down?
If it were bolted down, I would make it part of the vehicle.
Okay, so it could move,
Yes,
so there could be friction on the chair.
yes.
Um,
Here's a hint in terms of if there could be friction. Friction does require a normal force at that surface of contact. So anywhere I've got a normal force pair, there could be friction. It is also possible to have normal force without friction, but it is not possible to have friction without normal force. So anywhere I've got a normal force pair, you should be going your mind of, is there friction there? All right, so anyway, back to where we were. So which way is friction acting on the chair?
It's following the car, it's just going with the car, so I guess the desired motion is this way, so the friction will be going that way.
On
The chair.
All right, so if this were a frictionless surface here,
Yeah.
which way would the chair move relative to the car?
To the left,
Therefore,
friction is to the right. Is it an okay set of mind to think like that? Like, if there was no friction, which way would this go?
yeah, I find that an incredibly useful way of dealing with a lot of these.
Okay, especially if there's motion involved. Like,
Yeah.
Now,
And if, there are some situations where, and mistakes on my part where I set it up and I'm going, ooh, I didn't give enough information, I guess you could make an argument, friction goes the other way. If I mark it off, then on the test, for example, then you bring it back up and say, hey, wait a second, how about, here's what I was thinking, and occasionally I go, oh, yeah, I guess there was another way of looking at it. Then I embarrassingly mention it in class and give people some points back.
and get thrown tomatoes.
So far, not yet, but, you know, it can happen. All right, there's 2 more pairs to go.
Garrow,
We already did Garrow.
Would it be with
not Garrow.
an intro in the chair?
Edro the chair,
Edro.
which way is it acting on Edro?
I forgot it was inside.
And on the chair? And 1 more pair to go.
The stick.
Yep. Which way is the friction acting on the stick? You got a stick right here. Think about which way my hand is sliding on the stick when I move my hand this way.
Well,
So, okay, so relative to the stick, my hand is moving which way?
down.
And therefore, friction opposes that. So the friction on the hand would be,
Oh, is
R. And friction on the stick.
Would be
My hand's dragging down the stick. That's this one. It's the combination of these 2 forces which should add up to a horizontal force, which is what he's implying.
I see.
This is a test level problem.
Now, for the test, would we just be given all of this information, and we have to find all the forces that are acting on everything?
Yep.
Okay.
And occasionally I'll do if you want to know, I'll tell you how many forces there are, which some people take advantage of and some don't. I mean, it's a double-edged sword. Let's say you had 34 forces and there are 34, might be feeling pretty good. Let's say that you have 34 forces and I tell you that there's only 28, or I tell you there's 40, you know, and some people want to know and some people don't.
So is this all for that one question?
And this is why our quizzes are 2 questions.
Would we ever get a question where the rope is not ideal?
Not at this point.
Would we get it
Like if there was slack or something?
No, not so, like, we, at some point, and there's some choices I still need to make in terms of which content to go over versus others. If we go into rotational motion in depth, then we'll do away with the frictionless aspect of it, and the rope will now start turning the pulley. We have to take that into account. The stretching, we would not do, and the massless aspect, I would not do in 151. I would not remove the massless aspect in this course. Questions before we actually get past the first letter of facades?
first letter of what?
Facades. Oh, you weren't here for that.
Oh, facades, yes.
All right. Hey, let's just stretch our legs for 5 minutes and we'll come back and continue some rejoicing.
So, we didn't have a lab today?
That is correct.